Hi there, my name is Jason Smith, and I'm the Manager of Safety and Loss Control with Berkeley Electric Cooperative. I'm joined here today with two of my colleagues.
Teddy Jeffords, Safety and Loss Control Specialist.
Kenny Enfinger, Safety and Loss Control Specialist.
And we're here today to take you through our hotline demo trailer demonstration. Let's go. The first thing we want to talk to you about today is generator safety. And that's a big part in this demonstration because our entire hotline demo trailer is run off of a generator backfeed. So please do not try this at home. All right. As you can see here, we have a Honda generator that's hooked up to our trailer, and we're actually backfeeding through this transformer. Transformer are dumb devices. The way they typically work is primary voltage comes into the top, goes through the windings, and comes out the bottom as secondary voltage, which is then brought into your house. However, if a generator is hooked up incorrectly, it can also feed the opposite way, where secondary voltage comes into the bottom, goes through the windings in the transformer, and comes out the top as primary voltage. In this particular case, we're getting over 7,000 volts on our trailer to perform the demo today. Teddy, will you show them? While generators can be extremely useful, especially during times of storms, hurricanes, tornadoes, things like that, we ask that you properly have them hooked up by certified electricians. That way we can help keep our employees safe as well as the members. Which leads me to my next talking point of members. After a storm, I know you want to get out there and you want to help us. You want to cut trees off the lines, you want to clear it out so we can come in and restore power as quick as possible. But we're asking you to please stay away from down power lines in case a generator is hooked up incorrectly and it backfeeds out on the line. It can cause deadly voltages and be harmful to you and anybody that's close by. The next thing we're going to talk about is ladder safety and clearances around energized conductors.
Now we're going to discuss some line clearances and what to do when working with a ladder. As you can see, our top line is energized to 7,200 volts. Our lower lines, which is secondary lines running to your home, is going to have 120 volts per insulated leg, bringing 240 volts into your home. Those insulated legs could possibly have damage caused by weather, caused by squirrel damage, anything of that nature, so you want to watch out when using a ladder. Teddy's going to demonstrate what happens whenever you're not paying attention and you get that ladder into a primary line. The arc flash that Teddy made potentially has enough heat equivalent to the surface of the sun. Please keep in mind that those secondary lines can generate arc flashes just as hot as the one you just saw. Next up, Teddy's going to take you through some general power line safety.
To learn a little bit about power line safety, we got to know how the power works and where it comes from and what it can run through. Conductive material is one of our main things. We use aluminum wire on the top of our poles for electricity to run through. Once it runs through those lines, we have different devices on the poles to conduct electricity that runs through and comes to your house. One of them is our cutout bracket. It's a bracket up on the top of the pole you'll see on most poles on top of transformers. The power runs down the aluminum wire, comes to the cutout bracket, and there's usually a fuse that bridges the gap that brings power down to your transformer, which brings it to your house. In this demonstration, we're showing you different conductive materials. The kite string that we got hanging on the cutout, we're gonna bridge that gap and we're gonna actually light up the meters down here below and to show you even a kite string can be conductive material. Kenny? There's 7,200 volts running through the kite string all the way down to the transformer, which is lighting the lights at the houses we have down here. There's different types of conductive material, all types of conductive material. When it's dirty, it's easier conductive. When it's wet, it conducts easier. I'm conductive material. That's why we stay away and we use certain devices and certain things that we can stay away, as rubber gloves and a stick. I just want to remind everybody to stay away from any energized equipment, at least 15 feet away. It's better for your safety. I'm gonna go ahead and send you over to Jason to talk about PPE and how our guys use it to keep them safe.
So we've been talking quite a bit about why to stay away and the safety measures, you know, for you out there. But now we're gonna talk a little bit about how our employees are able to work on power lines safely. And I'm gonna use Teddy here as my demonstration, but as you can see, he's wearing certain PPE or personal protective equipment. We'll start with the hard hat, which is a Class E hard hat. That's what all our linemen out there wear. It's non-conductive hard hat. It also helps them, you know, keep things from hitting them on the head and knocking them out. The rubber gloves that Teddy's wearing, those are actually Class 3 rubber gloves. They're tested monthly dielectrically to 30,000 volts to make sure that whether they're out working on our 7200 volt or our 14400 volt system, we've got plenty of protection there. The safety glasses, they also go through an ANSI standard, and that way we can make sure that if there is an arc flash and debris blows at them, they've got protective lenses in them to keep them safe. As you can see here, Teddy's wearing flame retardant clothing as well. So if there is a problem, that clothing will actually self-distinguish and won't continue to burn and end up leading to more damage, to more harm to Teddy if he was in the event of an arc flash or something going wrong. So getting down to the demo, what we're gonna show you first is Teddy's got this piece of copper here. This copper is gonna represent a human body, okay? And he's gonna show you what happens when the human body gets between a primary conductor and a neutral conductor. Okay, as you can see, that electricity was taking a path to ground, back to the neutral, back to ground, and that's what drew that arc. Okay, electricity not only takes the path of least resistance, it takes all paths. That's one of the common nomenclatures that people kind of sometimes misinterpret. They say, well, it's gonna take the path of least resistance. Well, it is, but it's gonna take every path it can. All electricity wants to do is get to ground. So in this particular case, the little simulated human body was actually the path to ground. Okay, so now what we're gonna do is we're gonna take one of the rubber gloves. These are the gloves just like what our employees wear. Like I said, they're tested dielectrically monthly. Our employees will actually visually test them before every use. They'll go through and they'll look for holes, they'll look for cracks. They can do a air test where they blow them up like this, get the fingers big and expanded. And then we also have pumps on the trucks that they can put on there and pump them up so there's plenty of air to make sure they have no pinholes. So what I'm gonna do now, we're gonna set this on our simulated human body, and Teddy's gonna show you how when he uses the rubber glove that's good, he can sit there and touch the primary conductor. As you can see, nothing's happening. That rubber glove is protecting him. It's protecting that path. So he can sit there all day and work on that and have no problems. Now, same rubber glove. What we're gonna do is I'm gonna poke a little hole in it. Okay? Tiny little hole. Don't know if you can even see it. It's a tiny hole there. And we're gonna put this on our simulated human body. Okay, now Teddy's gonna put it back up there, and this simulated human body is gonna go back to work on our primary voltage just like before. Okay, now we got a big hole. So as you can see, it took that tiny pinhole we had, burned a big hole, and completed the path to ground. This would seriously injure or kill somebody in this particular case if that was a person up there and they had that little hole. So it's extremely important for our employees to make sure they're doing the proper checks, to make sure they're going through the proper procedures. And that's why we have all these checks in place. We have monthly checks, we have daily checks, we have usage checks. It seems redundant at times, but it's very, very important. So the next thing I'm gonna show you now is the effect that this electrical arc would have on this hot dog. This hot dog is going to represent the closest thing we can to human muscle. The copper here is going to represent the body, as I said before. And what you'll see is with an electrical burn, it'll actually cook from the inside out. It's actually quite graphic, but it is the nature of what we're dealing with. As we might have said earlier in the demonstration, you know, electrical arcs can be 35,000 degrees, which is hotter than the sun. And what it'll do is it'll run the path of the body underneath, especially like your bones. This copper could represent your bones, and it'll run through your meat. And you'll see when we get done with this, I'll actually cut it open and let you look, and you'll see where the electrical burn is burning on the inside, the whole path of where this simulated bone is. Okay, so that energized circuit did the same as what we said before. It completed its path. As you can see, the entry wound is pretty significant. The exit wound, not so much. You can't even hardly tell. So let's cut this open, show you what it looks like on the inside. So that's the inside. You can see the burn all the way down the inside. The outer layer looks just fine, but the inside of it is burned from the bottom up to the top, or I should say from the entry wound to the exit wound. And this is what it actually does to the human body, and that's why electrical burns are so severe and they've got to be treated appropriately, is because everything on the inside cooks, including your organs, your tissues, your blood, and it's immediately got to be looked after a staff that deals with electrical burns. All right, now that we've gone through and showed you how our linemen and our employees are able to work on energized conductors, we're going to take you over to a simulation that represents an automobile being in an accident and a down power line coming down on that car. And we're going to talk to you a little bit about what to do in that scenario.
All right, as Jason was talking to you about, we're going to demonstrate what happens if a power line falls on a car. Here we have our garden cart that we're demonstrating as a car. This is our car right now. And if you notice, on the back of it, we have a line that runs all the way to the top of our line, back to our power line. This is what's going to energize our car. Kenny, can you energize our car for us? Believe it or not, right now, our car has got 7,200 volts on it. Demonstrating as a car hit a pole and a line fell on it, and now it's energized. Can you hear the electricity? Can you see the electricity? Do you know that that car is energized? There's a non-conductive material that's actually saving that car from being in flames and be able to hear it and see the arc, is your rubber tires. Your rubber tires right now is what's saving this person right now inside of the car from being electrocuted. It's like a bird on a line. Kenny, can you demonstrate how much power is on the car? Our car is energized at 5,000 volts. We're going to demonstrate now what happens when you're in the car and you get out, or you don't realize that your car is energized. When you're sitting in your car and the power line's on top of your car and you're sitting inside of it, you're fine. You're like a bird on the wire. Like I said earlier, your tires are actually keeping you safe inside the car, okay? The only time that you need to get out of your car is if the car's on fire. But Kenny, can we hear the power? Can we see the power? No, you can't. Can you demonstrate if somebody walked up to the car to try to save that person? Our car here is energized over a little bit over 5,000 volts. Now, in this case, the only time that we need to be able to get out of a car is if it's on fire. We ask you, for your safety, to always stay in your car if there's a power line. We don't know if it's energized or not at that point in time, but the only time you need to exit if your car's on fire. You cannot stay in a burning car. This, we're gonna show you how to exit a car that has a power line on it if it's on fire. First of all, we're gonna get in a little ball on our seat and we're gonna open our door. Once the door is open, don't take your foot out. Don't step on the ground. You're gonna put your feet together right on the side of your car and you're gonna jump as far as you can, keeping your feet together. Once your feet are together in that first long jump, we're gonna keep our feet together and we're gonna shuffle away to get to a safe distance. We're gonna try to get at least 30 foot away from our car to where we don't have ground potential. Ground potential is when power fluctuates through the ground. As our car was energized, and we're not sure if the power line is actually touching the ground. Also, to keep you safe, there's voltage actually moving through the ground. So that's why we jump as far as we can away from the car. And once we do, there's different stages of power. This could be, where I'm standing could be 1,000 volts. And then the next step could be 50 volts. But this 1,000 volts wants to get to this area, this 50 volts, so it travels through your body to get here. It's an easier path moving through the ground. That's why we want to keep our feet together after our jump and shuffle 30 feet away to get out of your ground potential. Now I'm going to turn you over to Kenny. Kenny's going to go over how important it is to call 811 when you're digging around power lines.
All right, so now we want to talk to you a little bit about calling in for locates before you dig. That number is going to be 811. It's a statewide number you can call for utilities to come out and mark their power lines. What we have here is we have a simulated yard set up to where Teddy is going to be digging, let's just say, for instance, planting a tree in his yard. Unfortunately, Teddy didn't call to get a locate. There's different things that could be located in that you could have in your ground as far as utilities go. Power lines being one of them. What we have here is Teddy has a shovel and he's going to demonstrate now what happens whenever you don't call and get that locate. Fortunately for Teddy, he's equipped with his proper PPE. Now, if Teddy were at home and didn't have his PPE, it could have potentially been fatal. This is why we highly recommend you call 811 for a locate. Now let me explain a little bit on how our underground system works. What we have here is a riser pole. It comes down off of our overhead line and it's fed into an underground transformer. This underground transformer takes 7,200 volts or 14,400 volts and converts that into low voltage power, which runs on secondary lines into your home, feeding your house. We recommend that if you see children using this transformer as home base, this has the potential to be energized to those primary voltages. On the outside of every one of our underground transformers, it has signage and a lock. The signage says that you must stay 10 foot away from it. You cannot plant any obstructions in front of it. This helps our linemen to be able to access transformers in the event of an outage or to perform routine maintenance. If you notice that any locks or signage is missing from this transformer, please call your local electric utility. The next thing we want to discuss is outages, especially on a nice day like today.
All right, as Teddy said, the next thing we're going to talk to you about is outages. We all expect outages during a major storm, a hurricane, a tornado, a bad afternoon thunderstorm. But what about on a day like today? People all the time say, it's a perfectly clear day. Berkeley Electric Co-op, my power's out again. What happened? Next thing we're going to simulate to you is one of those things that could potentially happen on a clear day like today. What a lot of people don't account for is Mother Nature, okay? As we've demonstrated several times throughout this process is electricity is searching out all past the ground, okay? And as we simulated earlier with the rubber glove and the little simulated copper human, electricity will take that path from the primary down to the neutral, down to ground. Well, animals are the same way. They work the same exact way. A bird on a wire can sit up there all day long because it's at the same potential. It's not making a path between a ground or a neutral and a primary. It's just on one potential voltage. However, we have squirrels, raccoons, and birds that get into our equipment all the time. And trust me, it causes us just as much headaches as it does you. Kenny's gonna demonstrate with our wolf squirrel what could potentially happen when a squirrel runs out from a service on a house out on a triplex and gets up into the transformer. And the reason why we do this is a lot of people like squirrels. A lot of people feed the squirrels, they bring them around their house. But do know that that can cause an outage, not just for you, but it could cause an outage for a lot of people depending on how far the next protection device is. So Kenny, do you want to go ahead and demonstrate our wolf squirrel here running out on the triplex? As you can see, they can move anywhere they want. They're gonna get out, they're gonna make contact. So what he did there is he actually completed a path from the hot side or the primary side to the grounding lug and the tank of the transformer. So just because it's a nice clear day doesn't necessarily mean that you can expect absolutely no outages. There's a lot of things out there, including Mother Nature, that we just can't control, nor can your other energy provider if you have somebody else as your energy provider. One of the last things we want to talk about and show you here while we're on this, and we're showing you, is secondary voltages. For most of the demo, we've actually talked about primary voltages and how deadly they can be. Secondary voltages can be extremely deadly as well. Our meters are sealed for a reason. We don't want members going in there. We don't want people that are not qualified employees of your power company going in there because they can be extremely dangerous as well. The lower the voltage, typically the higher the arc flash. Obviously there's some other factors that go in there, but that is the basics of electricity. So what Kenny's gonna do is we have this meter right here in this meter base, and he's actually gonna go and attempt to move it. And we're gonna show you what could potentially happen. Obviously he's gonna have all his PPE on. He's working on the end of a insulated, tested approved stick. But if you're not, and you go out there and you start messing with these things, these arc flashes, these explosions, this electricity searching path to ground can flow through you. So we just ask that you give us a call. Anytime you're having work done, we'll come out there, we'll disconnect for you so that way you can have the work done safely. All right, and all that is 2 legs of 120 volts. So 120 to ground, 120 to ground, 240 if you go across the two. And you can see the damage that did right there, or that it potentially could do. All right, that wraps up our hotline demo demonstration, and we really hope you enjoyed it. We hope it was informative and that you learned something from it. If you'd like us to come out and do a demo for your work, for a school, first responders, please feel free to call us at Berkeley Electric Cooperative. We're here to serve you. We're here to educate the membership and the community to make sure at the end of the day that we're all safe and we all get home to the ones we love. Thank you again. Have a great day.